In lesson 2.5, we'll be doing solving compound inequalities. A compound inequality is an inequality formed by joining two inequalities with the word and or the word or. Writing and graphing compound inequalities. The graph of a compound inequality with the word and is the intersection of the graph of the inequality. The graph shows numbers that are solutions of both inequalities. So for example, here we have x is greater than or equal to 2, and we have x is less than 5. We have that is two different inequalities, but when they are combined together, that they are going to intersect with each other, meaning that every number in between those two inequalities are going to be a solution. Now, when you have the compound inequality with the word or, means that the graph shows numbers that are solution of either inequalities. They are graphed within the same line, but they're going opposite direction. So think of it one being crashing into each other, that's the intersection, and the other one is where they're going the opposite way. In example 1, we have part A. A number x is greater than -8 and less than or equal to 4. I already know that I'm going to have two separate inequalities here because of the word and, correct? So do not get confused with the less than or. Right here, this belongs all together. So I'm going to first graph this first part. Well, it's x is greater than -8 and x is less than or equal to 4. Okay, that is when the end. Remember, end is telling us that it's the intersection of these two inequalities. But a compound inequality with the word and can be written as a single inequality. How do we write it with the single inequality? We're going to flip this first one here. Always start with your lower number. Here we know is -8 is lower than 4. So we're going to flip this, which is going to become -8, is now what? Instead of being greater than, is going to be less than x. And x is still correctly what? X is still greater. We're going to combine this second expression as how? We're going to leave it exactly. X is less than or equal to 4. If I was to graph it, we're going to have what? -8 here, about a 0 over here, and a 4 around here. My -8 is going to be a open circle, correct? It's going to be an open circle, and it's going to go where? It's telling me -8 is less than. But because the negative, it's in reality going to go where? I'm going to graph to my right-hand side. And I'm going to stop right before the 4. My 4 is a what? A less than or equal to inequality. So it's going to be a closed circle. And I'm going to graph to the left-hand side. And that is the intersection. In part B, we're going to do it again. I'm going to first pay attention to what is its axiom. It's going to be or and. A number y is at most 0 or at least 2. In this case, we have the word or. So we're going to have y is what? Is at most. That means it's going to be less than or equal to 0, or y is what? At least 2. That means it's going to be greater or equal to 2. Finally ready to do what? Graph. I have my 0 here and my 2 around here. My 0 is going to be closed correctly. Closed circle, and I'm going to the left-hand side. My 2 is going to be a closed circle, and it's going to the right-hand side. So a good way to always remember is if your variables, for example, if your variable is x is greater than let's say 1, or x is less than 1, or x is greater than or equal to 1, or x is less than or equal to 1, that means my variables are on these sides, right? So what would I do? I'm going to graph the direction that, if you pay attention, it looks like an arrow, looks like a little corner, right? It is telling me to go. So in this case, this first one, I'm going to go what? Graph to my right, this one to my left, right, and to my left. But now let's say I have my variables on the right hand side. So I'm going to have, let's say 1 is greater than x, 1 is less than x, 1 is greater than or equal to x, and 1 is less than or equal to x. I'm going to do what? I'm going to go opposite, okay? I'm going to go opposite of where my error, like we did, our told us before, right? So we're going to go what? This first one, we're going to go backwards. The opposite way, correct? This one's going to go to your right, this one's going to go to your left, and this one's going to go to your right. So just really, really pay attention to wherever it tells you, wherever you see, okay, wherever you see your variable. So that's just like a trick. If you see your variables on the left-hand side, just go where the arrow is telling you, is pointing at. And if it's on the right-hand side, just go opposite of what it's telling you to go. Now we have solving compound inequalities. You can solve a compound inequality by solving two inequalities separately. I'm going to show you two different methods. You're going to do whichever one you find easier for you or you're the most comfortable with. So I'm going to do A with method 1 and B with method 2. Okay? So in part A, I'm going to do what? When a compound inequality with n is written as a single inequality, we can solve the inequality by performing the same operation on each expression, meaning let's separate it. So I'm going to have what first? Here is going to be -4 is less than x minus 2, and x is less than 2. I'm sorry, not less than. X is minus 2 less than 3. Correct? So let's solve here. What am I solving for? Obviously, we're solving for x, correct? So we're going to add 2 to both sides. And I'm left with what? -4 plus 2 gives me -2 is less than x, because this one cancels out. And then we have what? Plus 2 on this side, and x gives me less than 5. And always make sure to write the word and in between, because there's an intersection there. And now I'm going to do what? I'm going to write it as a single what? As a single what is it? As in a single inequality, correct? Okay. So now I'm going to, in a way, do I have to flip this one? -2 is less than x? No. It's already given to us. So we're going to have -2 here, 0, and 5. My negative 2, I'm going to leave, it's going to be open. And I'm going to go to the, remember my variable, it's on the right-hand side. So I'm going to go to the opposite of it's telling me, on the opposite direction. So I'm going to go to my right-hand side. And my 5 is going to be open. And I'm also going to the left-hand side now. Okay, that is one way to solve it. Now we're going to have method 2. Method 2 is, instead of me separating, I'm going to work the equation, not the equation, so the inequality within here. So if you see here, I'm solving for x. X needs to be left in the middle of when it's and by itself, because the x, remember, when it's in the middle, it's basically and. So I'm going to have negative 1. I'm going to get rid of negative 1 because I need to start isolation, right? But remember, when you do to one part of an equality, you need to do it to all other terms. In this case, we're doing our what? Constant terms. An equality sign is almost like an equal sign. That means that they are separated. So we're going to be left with negative 3 minus 1 gives me negative 4 is less than. This cancels out. We're left with negative 2x is less than or equal to 8. Correct? Now, I still need to solve for x. So what's in my front of my x? A negative 2. So remember, always a variable next to a number, you can means it's multiplication. We can only get rid of it by the inverse, which is correct, multiplication. So here we're going to, not multiplication, division. We're going to divide by negative 2. Did we divide by a negative? Absolutely. So we're going to flip our signs, okay? Flip our signs. That's very extremely important. Negative 4 divided by negative 2 gives me positive 2. This cancels out. I'm left with x. And 8 divided by negative 2 gives me negative 4. My inequality now is written as a single inequality. Am I ready to graph? Yes. So here, my lowest number is negative 4, right? So it's going to be negative 4 here and 2. 2 is actually a little bit closer, correct? Because it's closer to the number line. Is it going to be open or closed? 2 is going to be open, and it's going to the, remember, the opposite direction is going to go to the left-hand side. And my negative 4 is going to be a closed circle, and it's going to the right-hand side. Okay? Do whichever method you guys find easier for you. Both methods are going to give you the correct answer. Now we have solving a compound equality with the word or. Okay, with the or. What did we establish or is? It's the union, right? The graph is going to show that their solution is for either inequality. Okay, so here we're just going to do what? Solve it. We're going to solve it separately. Okay, we're going to solve it separately, but make sure you remember to write the word or. So here we have what we're getting rid of. 5, right? Which the inverse of negative 5 is positive 5. Let's do it in another color so that we can see. Okay, so it's going to be positive 5 on each side of the inequality. And I'm left with 3y is less than negative 3. Now I'm going to divide by 3. Y is less than negative 1, or, and the other expression we have getting rid of the negative 1. So in the inverse side is what? 1. Adding 1 to both sides. So we're left with 2y is greater than 6. I'm now going to divide by 2. I have the division property of equality. Y is greater than 3. Am I ready to graph? Yes, we have -1 here, 0 around here, and 3. Is the -1 going to be open? Yes, and it's going to the left-hand side. And my 3 is going to be open and it's going to the right-hand side. And that's with or. Just have to remember that your final answer, you need to make sure that the word or is in the middle. Okay, let's practice some writing the sentences and inequalities. Okay, here we have a number D is more than 0 and less than 10. We should first identify if it's going to be a one single inequality or a two expression equality, correct? Here we know that there's the first word, the word and, right? We learned that means I'm going to have a single. You could either start right away and doing it single or divide it and then add it. Okay, I mean by divided is do one section and then do the second part. So here's this. D is more than. D is what? More than 0. And, very important, D is less than 10. Right? If I am going to unite it, remember what I said? To do what? Flip. Okay, flip. So here we're going to have what? 0 is less than D. And D is less than 10. Correct. And number 2, we're not going to be graphing in the interest of time before the bell rings, okay? And number 2, we have what? A number is fewer than -6 or no less than -3. Again, we're going to have what? To read. But we have the word what? Or there. So a number A is fewer than. What is fewer than? Fewer means less than, correct? -6 or A is no less than -3. That means no less. Always go back to 2.1. Go back to 2.1 to always remember and help you study the inequalities. Okay, so A is what? Greater than or equal to -3. Do I need to combine these to a single? No, because the word or. Now we have number 3. A number P is less than 6 and greater than. Okay, I forgot. By the way, I forgot to write 2 here. But this means it's 2 right there. Okay, the 2. So we have what? A number P. I have the word and. And that means I'm going to first do two separate inequalities and then I'm going to combine them. So P is let's use a pen. Okay, P is less than 6 and P is greater than 2. Combining it, I'm going to have what? Remember what I said? In the number line, what number is always going to be first? 2, correct? So you want to start with 2. So 2 is going to be now what? Less than P, and P is less than 6. And number 4, we have a number N is less than or equal to. I know we could see the first or right there, but that's not the or we're looking for. That less than or equal to belongs together. It's going to be on the second what? On the second or, which is right here. Or what? Or greater than 12. Do I need to do eventually one single? No. So N is what now? N is less than or equal to -7, or N is what? Greater than 12. And that's your answer. Now we have fractions, correct? So here we're going to have which word? Correct, the word or. Again, two different what? Expressions. So we have M is more than. M is more than what? Correct. -7 2/3 or M at most. What is at most? Correct. Less than or equal to -10. And that's your answer. All right. Okay, let's continue with some practicing, continuing solving inequality. What are we going to do first? Yes, we're going to get rid of that 4 because we're solving for M to be by itself in the middle. Correct. So we're going to do -4 to what? Oh, correct. So all the terms that are constant. So we left with what's 5 minus 4. 1 is less than M because that cancels out. Less than negative what? No, 6. Correct. If I was to graph it, I'm going to have what? I have 1 around here and 6. Let me bold that. All right. Is it going to be the one open or closed? Closed. And I'm going to my, yes, the right-hand side. And 6 is going to be open, and I'm going to the left-hand side. Okay. And number 4, we're doing the same thing. We're solving for by K in the middle, yes. So we're going to have +5. I know it's a little bit messy. It's just the screen is very small. +5. I'm left with what? -3 plus 5 is 2 is less than 2K because this cancels out. Less than 7 plus 5 is 12. And now I'm going to correct divide because I need to get rid of that 2 in my K. So what's 2 divided by 2? 1 is less than K. That cancels out. Less than 6. I'm going to graph 1 is kind of the similar, right? So before 1 and 6. Is 1 now going to be open or closed? Open, and I'm going to the right-hand side. And my 6 is going to be open and to my left-hand side. Correct. And finally, we have the word or. Everybody loves when it's or because it's separating. What's the first thing? We're going to get rid of that +3, which the inverse is -3. I'm left with what? 4C is less than or equal to -8. And we're going to divide by 4, which gives me C is less than or equal to -2. I have a lot of students, just because of 8 is negative doesn't mean that I am flipping my sign. No, I only flip it if 4 would have been negative. Let's graph it. I'm left with -2. And one side, maybe I should wait, right, to see if the other one is less. Let's see the other one. We're going to have +8 on both sides, and C is greater than 7. So we're going to have or C is greater than 7. Okay, worked out for us. 7 is over here. -2 is going to be closed. Then I'm going to the left-hand side. And C is going to be, because of I'm not seeing 7, it's going to be open and it's going to the right-hand side. In number 6, we have -1 to both sides, which I'm left with 2p is less than -8. Yes, divide by 2. P is less than -4. Or, which one are we getting rid of? Do not get rid of the -2 first. It's going to get rid of the -3 first. So I'm left with -2p is less than or equal to -4. Now I'm going to divide by -2. Did I divide by a negative? Yes. So it's p is now what? Greater than or equal to +2. And now I'm ready to graph. It's 4 positive, open or closed? Open to the left-hand side, and 2 is going to be closed to the right-hand side.